Welcome to my channel Fee Concepts CHM. This video is the sixth part of the series of gradient, divergence and curl. Here we will be seeing some additional problems based on gradient. We'll see the first numerical problem. The gradient of a function f of xy is equal to x plus y square. So we have to find the gradient of this function f, which depends upon x and y. So we'll substitute the del operator, that is I cap dabba by dabba x plus j cap dabba by dabba y, and also we'll substitute the function f, which is given, that is x plus y square. Now we will open up the brackets. So that will be I cap dabba by dabba x of this function x plus y square plus j cap into dabba by dabba y of the same function x plus y square. In the next step, we will differentiate first with respect to x. So with respect to x, we will differentiate here. We will differentiate x, that is 1. Differentiation of y square with respect to x is 0. So what remains here is only I cap. We are using the formula where we are differentiating. We are using the formula of differentiation where we are differentiating x raised to n. This is the formula to differentiate x raised to n, that is equal to n is the power of x. So n into x raised to n minus 1. So this formula we are using to differentiate this x. Same way here we have to differentiate, if you differentiate x with respect to y, that will be 0, and we have to differentiate y square, so we use the same formula, so that will be 2 into y. So the final answer is I cap plus 2y j cap. Next problem, let f of xy is equal to x square plus y square. Find the directional derivative at 1, 1 in the direction of minus I cap plus j cap. So again, first we'll find the gradient of the function f. So we'll substitute the del operator, I cap dabba by dabba x plus j cap dabba by dabba y. The function f is x square plus y square. And now we will open up the brackets. So that is done in this step. I cap dabba by dabba x of x square plus y square plus j cap dabba by dabba y of x square plus y square. And now we will differentiate as we had done in the earlier problem. First we will differentiate with respect to x, and here we will differentiate with respect to y. So we will differentiate the x term, that is x square. So the differentiation is 2x. And here we will differentiate y square with respect to y, so that is 2y. So the answer is 2x I cap plus 2y j cap. Now we have to find at this point, which is represented by the coordinates 1, 1. So we will substitute x is equal to 1 and y is equal to 1 here in this equation. So that substitution is done. And finally we get the vector 2 I cap plus 2 j cap at this point 1, 1. Now the unit vector in the direction of this vector minus I plus j cap we have to find. That will represent as a cap. How do we find the unit vector? That is given as the vector divided by the magnitude of this vector. So that is done. We have substituted the vector minus I cap plus j cap and divided by the magnitude. We find the magnitude as square root of the components. We have to find the square of the components. We have to add it up and then find the square root. So the components here is 1 and here also it is 1. So square root of 1 square plus 1 square. So that comes as in the denominator as square root of 2. So this is the unit vector. Now we will find the directional derivative at 1, 1 in the direction of this vector minus I cap plus j cap. So how do we find that? We take the dot product of the gradient which we have found. We find the dot product of this gradient with the unit vector a cap. So we substitute the gradient of f which we have derived in the earlier slide, that is 2i cap plus 2j cap dot this unit vector is substituted here, and now we have to take the dot product. So the dot product will be this 2i cap dot minus I cap. So I cap dot I cap is 1. So we get minus 2 plus this is the dot product of 2j cap and j cap. So that is again j cap dot j cap is 1. So here we get 2. So the final answer is minus 2 plus 2 is 0. So final answer is 0. Next a problem is you have to find the gradient of the function f, which is given as x square y cube. So again we find the gradient of this function f by substituting the del operator and the function. Then we open up the brackets here as we had seen in the problems that we have in the earlier slides. I cap of deba by and I cap into deba by deba x of x square y cube plus j cap deba by deba y of x square y cube. So differentiate here x square with respect to x, that will be 2x, y cube remains just like that. Here we differentiate this y cube with respect to y, so that will be 3y square. The formula I had written down in the for the first problem itself. On the side I had written the formula of differentiation. So that formula we have to use. So differentiation of y cube is 3y square, x square just remains like that. So this is 2x y cube I cap plus 3x square y square j cap. Next we have to find the gradient of the function f is equal to x plus 3y square. Again we do the same steps. We substitute the del operator and the function. We open up the brackets and then we differentiate here first with respect to x. So we have to differentiate x with respect to x, that will be 1. Here we have to differentiate 3y square with respect to y. So that will be this y square. Differentiation of y square will be 2y. So 2y into 3 is 6y. So final answer is I cap plus 6y into j cap. Next is the function given f is equal to x square y. You have to find the gradient of this function at 3 and 3, 2. Again we find the gradient in the same way by substituting the del operator and the function and opening up the brackets. Now you differentiate first with respect to x. X square, you are differentiating x square with respect to x, so that is 2x, y remains just like that. Here we differentiate y with respect to y, that will be 1, so only x square remains here. Next we have to substitute this the coordinates x and y. X is 3 and y is 2, so that is substituted here in this step, and finally you get the vector 12i cap plus 9j cap. Next, find the directional derivative for f of xyz is equal to x square y cube minus 4xz in the direction of minus I cap plus 2j cap. This kind of problem also we had just seen earlier in the earlier slides. We have to find the gradient. So again we substitute the del operator here. I cap deba by deba x plus j cap deba by deba y plus k cap deba by deba z, and the function is substituted, that is f. And now we will open up the brackets and we will differentiate first with respect to x, then with respect to y, and then with respect to z. So here in the first bracket with respect to x we have to differentiate x square, that will be 2x. Rest of the things or the rest of the terms remain the same. Here we will have to differentiate this y cube with respect to y. So that will be 3y square. Yeah, here we have to also differentiate this x here. So that will be 1. So here minus 4z remains. Next we have to differentiate this bracket with respect to y. We have to differentiate y cube, that will be 3y square. Then we have to differentiation of 4xz with respect to y will be 0. Then in the third bracket we have to differentiate this first term. There is no term of z, so the differentiation will be 0. And the differentiation of z here in this term will be 1. So what remains is minus 4x. So finally you get this vector 2xy cube minus 4z into I cap plus 3x square y square j cap minus 4x k cap. We'll find the unit vector. You have to find here, it is given. You have to find the unit vector in the direction of minus I cap 2 plus 2j cap. So how do we find it? We find it, we'll denote that unit vector as a cap, and the unit vector is given as the vector upon its magnitude. So the vector is substituted and its magnitude. These are the components 1 and 2. So that will be square root of 1 square plus 2 square. So that comes as square root of 5 in the denominator. Now we'll find the directional derivative in the direction of the vector minus I cap plus 2j cap. So that is, we have to take the dot product of the gradient and the unit vector. Del f dot a cap, substituting the gradient and the unit vector. Here now we have to take the dot product. So this term 2xy cube minus 4z I cap dot minus I cap. So that is just minus 2xy cube plus 4z. Then the dot product of 3x square y square j cap dot 2j cap. So that will be 6x square y square. And here there is no term, the third term based on k cap. So the dot product will be 0. So final answer is 1 upon 2 pi or into 4z minus 2xy cube plus 6x square y square. Next, let r bar is equal to xi cap plus yj cap plus zk cap. The magnitude, that is magnitude of r bar and its square, is given as x square plus y square plus z square. We have to find the Laplacian of mod r bar square. So that is, we have to find del of r bar square. So we have substituting del square. This is del square of this mod of r bar square. So del square is given as deba square upon deba x square plus deba square upon deba y square plus deba square upon deba z square. And now we have substituted this mod of r bar square is substituted. And now we will open up the brackets as deba square of deba x square of this mod of r bar square. Same way deba square upon deba y square of this bracket plus deba square upon deba z square of this bracket. So now here we will have to differentiate twice. So we will first consider the first bracket. We will first differentiate this bracket with respect to x once. So differentiation of that will be, first we have to differentiate this whole function. So we will use the same formula to differentiate x raised to n, that is n into x raised to n minus 1. So your function, that variable x is this whole function x square plus y square plus z square. So, and its power n is 1. So 1 into x square plus y square plus z square raised to n minus 1, that is 1 minus 1. Also we will have to differentiate x square, so that is into 2x. So finally here this 1 minus 1 is 0. So this bracket is raised to 0, that is 1. So you get final answer as 2x. So again now one more time we have to differentiate with respect to x. So we will differentiate this 2x with respect to x. So you get the answer as 2. Same thing we have to do with respect to y. We have to differentiate with respect to y twice. So that answer also is 2. Same way we will differentiate with respect to z twice. The answer is 2. Substituting everything in our equation that we had written down earlier. That is 2 plus 2 plus 2. This is del square of mod of r bar square. So that is 2 plus 2 plus 2 is equal to 6. Thank you for watching this video.